Question 9. Points A and B lie on a horizontal ground. At time t equals 0 seconds, an object P is projected from A towards B such that AB is the range of P. The speed of projection is 24.5 meters per second in a direction which is 30 degrees above the horizontal. A. Calculate the range AB of the object P. So we've got a question about projectiles, so if we draw a diagram. So we have the projection as a parabola. The angle of projection is 30 degrees and the velocity is 24.5. So we want to look at components. So the horizontal component is 24.5 cos 30 and the vertical component is 24.5 sin 30. If we look at what's happening vertically, so vertically u is 24.5 sin 30, which is 12.25. The acceleration is minus 9.8. It's minus because it's downwards. Everything positive is upwards. And we want to find when it comes back and hits the ground again. So vertically, the distance, the displacement is going to be 0. And the time is going to be some unknown time t. So we need an equation that connects u, a, s and t, and that is s equals ut plus a half at squared. So s is 0, u is 12.25, t, half of minus 9.8 is minus 4.9. And we've got t squared, so we've got this quadratic equation to solve. We see there is a common factor, so we take the t out and we're left with this, which means that t is 0, or t is 12.25 divided by 4.9. And if we look that up, it is 2.5. So t is 0, which is at the beginning, and it's at that level, s is 0, and t is 2.5. So that is our time that this takes in those 2.5 seconds. So we must look at things and see what happens when we're looking at things horizontally. So if we look at things horizontally, u is 24.5 cos 30, which is equal to 49 root 3 over 4. Acceleration is 0. The distance travelled is this range that we want to find, so we could call it r, and t is 2.5. We want an equation with u, a, s and t, so we're using s equals ut plus half at squared again. So s is 49 root 3 over 4 times 2.5. Half of a is 0, so we've got our distance there which we need to evaluate, and that is equal to 53.04 meters. Notice that we have this equation of motion, but we could have just said it's moving with constant speed because this acceleration is 0 and speed is distance over time. So we can get the speed is the distance over time, or the distance is the speed times the time, which is what we have done to work this out. So if we now move on, at time t equals 1 second, another object Q is projected from B towards A with the same speed of projection, 24.5 meters per second, and in a direction which is also 30 degrees above the horizontal. Determine the height above the ground at which P and Q collide. So we might first of all want to think, well, if they're travelling from in opposite directions, will they definitely collide, or could they miss one another? But the first particle is projected from A with a speed of 24.5 meters per second at an angle of 30 degrees to the horizontal, and the second object is projected at the same speed and in the same direction from B to A, so they should meet. It is the same path, so we can then investigate what is happening now. So if we draw a diagram, we've got the projectile and one particle has a speed of 12.25 times root 3, which we found out earlier, which is projected from here, and that's the horizontal component, and this one has a same component, 12.25 root 3. Let's imagine that the projectiles collide at C, and so that this projectile would travel a distance x1 and this projectile would travel a distance x2. So the particle projected from A has an initial speed 12.25 root 3. The time it takes, let's say that is t, to get to this collision point, and it travels a horizontal distance x1. Particle B, or the one that starts at B, has initial speed 12.25 root 3. The time is t minus 1 because it starts 1 second later and it travels x2. So both of these have no acceleration because we're just thinking about moving horizontally, and so we can just use speed as distance over time, or distance is equal to speed times time. So x1 is 12.25 root 3 times t, and x2 is 12.25 root 3 times t minus 1. But both those distances added together is the answer that we got from part A. So x1 plus x2 was equal to 30.623 root 3, or the 53.044 meters that we got earlier. So 12.25 root 3 times t plus 12.25 root 3 times t minus 1 is 30.623 root 3, and the root 3's will cancel. So 24.5 t minus the 12.25 is the 30.623, so 24.5 t is equal to 30.623 plus 12.25, which is 42.873. So t equals 42.873 divided by 24.5. But if we kept the accurate display for our answer from the first part, this will give us an exact answer that t is equal to 1.75. So if we now look at what's happening vertically, if we look at the particle at A, u is 12.25, which we found earlier. The acceleration is minus 9.8. It's opposing the motion, and positive frame of reference is upwards. T is what we've just found is 1.75, and we like to find S. So we want to use s equals ut plus a half at squared. So s is 12.25 times 1.75 minus 4.9 times 1.75 squared. So we just need to evaluate that. So this gives us 6.43125, about 6.4 meters. We could have also looked at this another way by looking at what was happening vertically. So this particle had an initial speed of 12.25 vertically. A is equal to minus 9.8, t is time t, and s is some height h. U is 12.25, a is minus 9.8, but the time, this one went 1 second later, so the time is t minus 1 again, and s equals h. And if we look at what happens and combine our values of the height each time, we could solve again. So using s equals ut plus half at squared, h is equal to 12.25t minus half of 9.8 is 4.9 t squared. So that's looking at the particle at A. We could do the same for the particle at B. This uses s equals ut plus half at squared again, so h equals 12.5 t minus 1 minus 4.9 t minus 1 squared. But we could combine both those equations. This gives 12.25 t minus 4.9 t squared. This one is equal to 12.25 t minus 1 minus 4.9 t minus 1 squared. So we get 12.25 t minus 4.9 t squared is 12.25 t minus 12.25 minus 4.9 t squared. Then when we times out, we get a minus t minus a t minus 2t times minus 4.9 is plus 9.8t, and minus 1 times minus 1 is plus 1 times minus 4.9 is minus 4.9. But if we look at this equation, it's not as bad as it looks because some terms are going to cancel out. So we've got minus 12.25 and minus 4.9. Let's take those to the other side, and we get 17.15 is equal to 9.8t, and this gives us t equals 1.75. So we'd have the same answer as we got previously for t, and we could go on like we did previously to find out what happens to get the height where the two particles collide. So we could still use the same method there, but this was a different way to finding the time when they did collide.
Just for a bit of fun really, we'll have a look at what this would look like in real life, and we can see that if we slide this along, P starts to make its parabolic path. When we get to t equals 1, then Q appears and starts to make its path, which is of course a reflection of P's path, and then we see that at 1.75 they meet. If bizarrely they were able to pass through each other, I mean one could be perhaps a cylinder and the other one could be a sphere able to pass through the cylinder, then this is what would happen. We're now going to have a look at the situation in terms of the horizontal and vertical velocities. So if we put this in for the horizontal velocity, that will be a fixed value because, as it says in the solution to the question, there's no acceleration in that direction, and the length of that vector represents the size of the velocity. So given that, after a second in the horizontal direction, we would expect it to have travelled the length of that velocity vector. So we'll pop a line in there, and when we have a look at this in a minute, we'll check that that's what happens. For the vertical velocity, the initial vertical velocity is just over 12, 12.25, and so we've now set that up. So let's make this travel along in time, And what we see is that as we move it along, the horizontal velocity sure enough stays the same, but we can see the vertical velocity shrinking. So that's as the effect of gravity slows the vertical motion. At 1 second, sure enough, we have got that far. But then as we continue on, we get to a point where it's at its peak, and then the vertical velocity is 0, and then the vertical velocity starts to become negative, and it starts dropping down until we get to there where there is a collision. So that shows nicely how the two components change differently with the motion.